conference organizers. Especially thank you for choosing the discussant, and to him, where my co-authors and I are looking very much forward to his remarks and anticipate them being very helpful. With that, I am presenting Anomaly Time. This is joint work with Adam Reed, Matt Ringenberg, and Jake Thornock. Let me motivate this paper by characterizing what we think of as the problem, or a problem here, and that is that there are now over 400 documented anomalies, which all are apparent violations of market efficiency. That seems to be a problem, to have over 400 apparent violations of market efficiency. When we're thinking of an anomaly here, and this shouldn't be new to this group who's just been in the previous session, but we're considering an anomaly in a sense that there's a firm level characteristic that can predict future stock returns. That's why we call it an anomaly. The example I will use throughout this presentation, we're going to carry it from here on, is asset growth. Asset growth is a firm level characteristic. We learn about assets in the annual and quarterly financial statements. And then in the typical fashion, academic papers have thought about a relative ranking of assets at a certain point in time, say June 30th, and then form a long-short portfolio on the extreme deciles. So relative ranking matters here. We form this hedge portfolio, and because for asset growth and for almost 400 or over 400 other firm level characteristics, because this hedge portfolio predicts future abnormal returns, we call that an anomaly. It seems to be a problem. Not only is it a problem that we have over 400 of them, but the interpretation of these anomalies, especially the fact that there are so many of them, remains the source of much disagreement. Allow me to generalize a bit and think about, and talk about how we think about the disagreement. One way to characterize the disagreement between two camps. There are those on the left side of your screen and papers who suggest that anomalies perhaps were real, or that they never were real, they never really existed at all. In this camp, you can think about the 2016 paper by McLean and Pontiff that uses the publication date of anomalies to show that anomaly returns, or the predictability of abnormal returns, is diminished after publication date, suggesting that maybe anomalies were real, but after arbitrageurs learn about them, they eliminate them. They don't exist after publication, or at least are much weaker. Also in this camp are the Harvey et al. And I discuss it here in a recent paper, which suggests that anomalies never really existed at all. That the way I think about this part of the literature is it's not necessarily a market inefficiency that results in 400 documented anomalies, but it's an inefficiency within the academy. We face incentives to see 3 stars on our Stata output and turn that into a paper, and those incentives have resulted in data mining or p-hacking. The results are that we have over 400 documented anomalies, which may or may not be robust in the data. On the other side of this camp, there are those who have papers that provide evidence, and authors who propose these ideas that anomalies do actually exist and can be explained. That last paper I've cited is a relatively new paper where the authors ask the question, is there a replication crisis in finance? And they replicate many anomalies in different settings, different time periods, and outside of the United States. These other papers I've noted, though, are more like the original papers that document the anomaly for the first time. And I don't think they should be dismissed, because these papers, you think about the normal structure of them, is they find some sort of relation between a firm level characteristic and future returns. They show that it's somewhat robust. At least they capture a referee and a journal editor to get it published. And then they, almost without fail, provide some sort of economic explanation for why that return predictability exists. For instance, in Lakonishok, Schleifer, and Vishny, they propose the Sells growth anomaly and suggest that market participants misestimate future growth rates. In Slow 96, presenting the accruals anomaly, they suggest that investors fixate on earnings and don't think clearly about accruals versus cash flow components of earnings. The Cooper, Gould, and Schill paper, which is where the asset growth anomaly comes from, as well as Novi Marx, and many, I hesitate to say most, but many other original anomaly papers follow this pattern where they provide some sort of explanation based on a combination of over-under reaction, overconfidence, limited attention, or even limits to arbitrage. So there's the problem, there's the disagreement. And I want to propose, we want to propose a resolution. The resolution, question mark, that's what I'm here to convince you about. This is a resolution here. We propose that the delayed information processing theory provides a unifying explanation for a large number of these anomalies, for the fact that there is a large number of anomalies, and the fact that they have diminished in recent periods. We propose delayed information processing kind of as a unifying explanation. Let me walk through the intuition and the prediction, and then we'll talk about the main results of the paper. So the intuition is relatively straightforward, and we're going to use the simple case of the asset growth anomaly. I said we'd carry that one through. So consider an arbitrager who wants to trade on asset growth. That means take a relative ranking of firms and take a long-short portfolio of the extreme deciles. Well, the job of that arbitrageur is surprisingly complex, we argue. Not only do they have to rebalance their portfolio frequently, but before that, they need to be aware of any information that might come out that they need to incorporate into their relative ranking of stocks based on asset growth. So they've got to be aware of information. And even if one firm reveals new information about assets, and I want you to think about an annual financial statement being released. Even if one firm reveals a new financial statement, then they have to re-rank all their stocks, potentially rebalancing her entire portfolio based on one piece of information that comes out. Now, this can seem somewhat simple if we're in an environment or a time of the year where there's not a lot of information coming out. But if you're in a period of the year like early January, February, and March, when there's lots of information being released, arbitrageurs face somewhat of a complex problem. As there's lots of information, they need to be able to identify and process the right pieces, re-rank stocks, and potentially rebalance their portfolio lots of times. We argue that it is unlikely an arbitrageur would be able to do all these things instantly upon the release of new information. As a result, when new information arrives, investors update slowly, and so do prices. So the delayed information processing theory, as it pertains to anomalies, provides a few predictions that we're going to test. First, if anomalies are the result of delayed information processing, then return predictability should be strongest in the period immediately following the release of key information. Second, I used the word complexity earlier. If complexity reduces the speed of adjustment, then prices should reflect information more slowly, or prices should adjust slower as complexity increases. In this sense, we're thinking about complexity again from the perspective of this imaginary arbitrageur. If there's lots of information, lots of potential rebalancing, that's a more complex period than if there's a little bit of information coming to the market about assets, for instance, and not as much rebalancing going on. If complexity, the delayed information processing theory suggests that if there's more complexity, prices should adjust slower. Finally, the delayed information processing framework predicts that if information processing time and costs have decreased with improving technology, then return predictability should decline over our sample period. Further, prices should reflect new information more quickly over our sample. So in more recent periods, we should see return predictability diminish and prices adjusting faster to new information revealing stocks to be anomalous. This is one of the slides I want you to remember from this presentation. This next slide is the other. The rest of my slides, I'm not quite indifferent, but these are the two I really want you to remember. In this paper, we propose the delayed information processing theory underlying anomaly returns, and then we carefully consider the timing of anomaly relevant information releases and measure abnormal returns relative to the date of information release. That's what we do in this paper. We're very careful about when information comes out that reveals, for instance, a stock to be high or low asset growth. We do it for 28 different anomalies. And then we are very careful at measuring abnormal returns to those anomaly portfolios following the release of information. In a simpler sense, we look at anomaly returns in event time, anomaly time. This picture captures our main result. In the three columns you see here, the three bars are looking at annualized average daily abnormal returns based on the trading days after information release. And what you can see quite clearly is in the first 30 trading days, that's roughly a month and a half, after financial information is released that reveals a stock to be anomalous, put it in an anomaly portfolio, that's when the bulk of abnormal returns are earned. On the other side of this picture, between 121 and 240 trading days, very little abnormal return is earned, and for many anomalies, zero abnormal return is earned. This 121 to 240 days, this is roughly 6 months to a year after the information is released. Before moving on from this slide, which I mentioned I want you to remember, I do want to also mention that because we have to be very careful about identifying date zero in our event time setting and the timing of information releases, we use an overlooked but quite powerful data set, CompuStat snapshot database, to identify these dates of releases. And I'll mention a bit more of that in a couple slides. But to summarize, we use a powerful database, snapshot, to carefully consider the timing of information releases and use it to test the delayed information processing theory as an underlying framework to understand some recent evidence about anomaly returns. We find evidence that supports our predictions. As I just showed you, anomaly returns are mostly earned after important information releases. Anomaly returns are also more slowly earned when trading on anomalies is more complex. So when there's more information bombarding the arbitrager and more potential rebalancing going on, that's when prices are going to respond more slowly to new information. And third, anomaly returns have decreased and are earned more quickly in recent parts of our sample. So compared to the mid-90s and early 2000s to the later 2000s, 2010s, in this more recent period, prices aren't adjusting as much. There's a less abnormal return to be earned for these anomalies, and the prices are adjusting much faster in the first 2 to 5 days instead of in the first 30 or more days. Finally, I want we think about our paper as doing a couple other things, and that is that we sort of conduct an out-of-sample test for anomalies. For most of these anomalies, we're using over a decade of data that wasn't in the original paper, and also by looking at the time immediately after information is released, we're using data that typically wasn't used in the original papers that study these anomalies. Finally, we see our papers as a contribution because it can encourage future work in anomalies by bringing in this event time framework to study anomalies at large. All right, with my next 10 minutes, I want to talk about the key idea, the key technique, tests and results, and then I'll return to the summary, but just call it a conclusion. So I've harped on the key idea enough, but I want to do it one more time to be clear. The delayed information processing theory implies that information is slowly reflected in prices after it's released, which leads to return predictability. And I went through the intuition of imaginary arbitrager who has to re-rank all stocks if new information comes out, and it can seem simple, it's surprisingly complex if you think about the number of stocks. I also want to mention that we're carrying through this asset growth example. Well, asset growth is based on simply one accounting line item on the balance sheet, but many anomalies are based on as much as 20 accounting line items to calculate them. So you could think the arbitrager's problem is even more complex with those anomalies that they have to be aware of when different accounting line items are being released for the first time. We argue that it's unlikely an arbitrager would be able to do these things instantly, and as a result, when new information arrives, investors update slowly, and so do prices. The key technique here is to look at accounting-based anomalies in event time. As I've mentioned, we care about the time the date that information is first released and show that anomaly returns are related to that date or the distance between that date and when the anomaly return is earned. Now, to do that, we rely on a couple things. I've mentioned the snapshot database. I'll come to that in a second. But first, not all anomalies fit our framework, wherein we can identify event date 0. For instance, there at the bottom, I've noted we use asset growth because we know that when the annual financial statement comes out and we can see assets on the balance sheet, we know assets, that's date 0. But we don't use earnings to price. Prices change all the time. It's very difficult to identify what would be date 0 in your framework. So we start with a list of anomalies from McLean and Pontiff's paper, which is 97 of them. They actually have a category in their appendix that names some anomalies as fundamental or event anomalies, which fit our framework of identifying date 0 a little bit better. We further limit those 60 fundamental or event anomalies by requiring that they can be replicated using snapshot, which is very similar to CompuStat. You can think of it as we use 28 anomalies for which we can use the income statement, balance sheet, statement of cash flows, other financial information that come in annual audited financial statements. Now, it's important that we use snapshot because maybe you could be thinking, well, why can't we just use the earnings announcement? Why can't we use the 10K release date? Well, the information that gets released in an earnings announcement or a 10K filing, that has changed over time. Throughout our sample, approximately 53% of earnings announcements included a full balance sheet. But that hides what's been going on because since 2008, earnings announcements are much more than earnings announcements. They're actually providing, for the most part, providing a full set of financial statements to investors. And so we have to be careful because our sample goes from the mid-90s to 2018. We have to be very careful and use snapshots so we know whether on an earnings announcement date or on a 10K filing date, earnings is released or assets is released. And that's why we think snapshot is pretty powerful. Finally, what we do is we construct long-short anomaly portfolios using the most fresh information, and then we analyze returns over the next year. Here's briefly, you can look through the list of anomalies, or you can look in the paper. We have 28 of them, and they are should be unsurprising: asset growth, asset turnover, net operating assets, working capital, sample growth, sales growth. We have the usual suspects here. Let me start with our event type tests and get to prediction 1, which is that if delayed information processing is behind some of these anomalies, then we should see abnormal returns related to timing. What I'm showing you here is for our 28 anomalies, the annualized average abnormal return, but I'm looking at a specific window. This is an event time, so date 0 is when the information was released that revealed a firm to be in the high asset growth or low asset growth portfolio, leg of the portfolio. But notice this is in the 121 to 240 trading day window. So I'm looking 6 months to 12 months after the information is released. You'll get more context in just a second, but notice that half of the anomalies have statistically significant and positive abnormal returns, but they do perhaps look a little bit small, especially with this context. If we flip from looking at the 6 months to 12 months after information release to looking at just the first month and a half or 30 trading days, we see that anomalies, more anomalies are positive and significant, and the bulk of them are earning a higher return than in the previous picture. This is our first bit of evidence that anomalies, the abnormal return earned to many of these anomalies is related to the information release. And if you want to capture an abnormal return, you need to start trading early after the information is released, at least in the first 30 days. This is the picture I showed earlier. Again, if you take what we call a super anomaly, that's collapsing all these 28 anomalies together, you see that most of the return is earned in the first month and a half. The event time test is not implementable. We can't line up all stocks at date t equals 0. So we also think about an implementable version of trading quickly on anomalies and call it our calendar time tests. So consider that every day our imaginary arbitrageur can see new information that's coming out about assets or sales and update their anomaly portfolios. That's what we call here our information rebalancing portfolio. And then we compare it to the typical strategy. The literature has a convention where it comes from 1993 Fama paper, where at the end of June, we know most firms have revealed annual financial statements. So at the end of June, let's make our relative ranking. Let's grab the extreme deciles and form a portfolio and hold it for a year. That's the June rebalancing portfolio. So what we do here is we're comparing the abnormal return earned for these anomalies in the information rebalancing implementable approach of the event time strategy and the June to June rebalancing approach. And you can see the black bars are bigger than the gray bars. So it pays to trade quickly on this information, but I want to delve into this just a little bit more. Notice, calendar time matters. In the year between July and December, notice how similar the information rebalancing approach and the June rebalancing approach are. Extremely similar, and it makes sense why for 2 reasons. At the end of June, these 2 portfolios are essentially the same. However, it's second, as we go from June to December, most firms are not revealing new audited annual financial statements. Most firms are 12/31 fiscal year end firms that will report in January through March. So in this period of time, these two approaches start with the same portfolio essentially, and there's not a lot of new information for the information rebalancing approach to incorporate. However, as we move from January to look at specifically at January to June in the calendar year, we see a big difference. 2 reasons going on here. One, I already said, in the beginning of the year is when most firms are releasing audited annual financial statements, and so the information rebalancing approach is incorporating fresh, new information. And that's when, as we showed in the event time test, most of the abnormal return is earned. Whereas the June rebalancing approach is using data that is up to and even over 12 months old, very stale, and not any return to speak of earned to that approach. This is shown again when I collapse those 28 anomalies to what we call the super anomaly. We see the same story. So prediction 1, if anomalies are the result of delayed information processing, then return predictability should be the strongest in the period immediately following the release of key information. We find evidence that confirms that prediction, gives some weight to the delayed information processing theory. To our second prediction about complexity, again, we think of complexity as how much information is coming out in a period of days that the arbitrageur would have to pay attention to and how much rebalancing they would potentially have to do. And then we compare that to non-complex days. The delayed information processing theory says that, well, when things are complex, prices should adjust more slowly. And we indeed find that in the results. So this is considered our event time framework. If we're looking at not complex days, you'll notice that 11%, if we're looking at columns 5 and 6, 11% of the 30 trading day return is earned in just 2 days. And 1/5 of that 30-day return is earned in the first 5 days. So prices when times are not complex, prices are reacting faster. Whereas when things are complex, in the first 2 days, there's no response. In the first 5 days, half of what happened on the non-complex days is happening on complex days. Roughly 10% of the 30-day return is earned. So prediction two, we find evidence for it as well, that complexity reduces the speed of adjustment. Our third prediction was about as technology has improved over time, we should see some change in the speed of price adjustment for these anomalies. We divide our sample at 2007, 2008, and we can move these dates a little bit to divide the sample around this period. And we find the same thing, that in the early part of our sample, 90s and early 2000s, prices reacted slower. And if you look at the 30-day return, it was larger. So more abnormal returns were earned by anomalies, but they were earned a little bit slower in the first month and a half. Whereas in the most recent period, where we think of having more technological advancements and information processing should be more cheap and faster, there's less of an abnormal return. Column 3 shows 30 days is less, but that the portion of that abnormal return at 30 days that's earned in the first 2 or 5 days is higher. Prices are adjusting faster. We do a couple of other tests, and I'll go through them quickly for time. One is we kind of stop thinking about the hypothetical arbitrager and think about who are arbitragers in practice. Hedge funds can we look at hedge funds trading speed and see if they're trading on these anomalies and if that means anything for future performance? I'll be brief, but we essentially look at our implementable strategy. That's the calendar time returns. We have a daily return to that strategy. We consolidate that to a monthly return, regress that against monthly hedge fund returns, and the beta from those returns we call speeds. The covariance of the hedge fund's return with our implementable strategies returns is hedge fund speed. In column 3, we show that as hedge funds increase the speed at which they're trading on some of this anomaly information, they increase their performance. 1 standard deviation increase in speed results in an annual performance increase of 53 basis points. I'm out of time, so I just want to mention that we also look at transaction costs, and transaction costs, it is more costly to trade in this implementable version than to trade only in June. So if the June to June approach requires 100% turnover, the information rebalancing requires 140% turnover, and costs do reduce the abnormal return, but do not eliminate it. It's also related to arbitrage risk. I don't have too much time for that. I'll mention that our results survive when we look at large stocks, small stocks, or get rid of micro stocks. We still find evidence in favor of our predictions. So let me return to the conclusion. We propose and test delayed information processing as a unifying theory for the existence of a large number of anomalies and the evidence that many of them have gone away in recent periods. We use a powerful database snapshot to identify date 0 when information is released and look at abnormal returns in the next year. We find evidence that abnormal returns to anomalies are earned primarily in the weeks immediately following important information releases, and the speed of price adjustment or the speed at which these returns are earned is related to both the complexity of how much information is coming out and also to the technological advancements over time. Thank you, and I look forward to the discussant's comments.
Okay, great. Thank you very much, Boone. The discussant is Shen Zhu from University of Cincinnati. Screen is yours, Shen.
Okay, thank you, Daniel. All right, so let me. All right, first, thanks for inviting me to discuss the paper. It's a pleasure to read it. I really like some of the findings and the angle of this paper is really novel. Okay, so I would just first do a very brief summary of the paper. So there are 2 key takeaways from the paper. So the first thing, if you use more timely updated data, you can strengthen anomalies. In this case, it's more about accounting anomalies. And also anomaly returns, this is very interesting, is the realization is more concentrated in the period right after information release. So you see the connection to new information. And from the findings, we can draw several very important implications. The first thing is when you think about the recent decay of anomalies, right? So if you still follow the conventional procedure, the anomalies magnitudes can be understated. And also speaking to the debate on whether anomalies are spurious or not. So if they are spurious, then updating or timing shouldn't matter as much, which is not the case from the evidence. So the evidence suggests that anomaly is more real than previously thought. And the last one is how do we interpret anomalies if they're real? Do they reflect risk or mispricing? So the evidence here seems to be more consistent with mispricing because, right, we can link the release news information to the correction of anomalies. All right. So here's my quick impression. First, I think the results makes a lot of sense to me that if you use fresh information, you get stronger anomaly returns. But I think the improvement is very substantial. And the intuition is if you use stale information, they kind of add a lot of noise. So you have a noisy portfolio sauce, which will lead to weaker anomaly returns. And also from the presentation, we see that we exactly get more improvements during the second half of the 12 months holding period. Is most companies they end their fiscal year in December, and hence the actual information release tends to occur during the first half of the year. Okay, so if you do a quicker update, and then you get a lot of gains and improvements for anomaly returns. And the second thing is, I think a nice contribution of this paper is documenting this timing patterns of return realization following information release. Okay, and this complements the early evidence on anomaly returns realizations on news day. So, for example, we have recent paper by Engelberg, McLean, and Pontiff that show that anomaly returns tend to be a lot higher on earning announcement day. Okay, so the evidence is here. I would say just kind of complete the whole picture if you argue that anomalies are driven by mispricing. Okay, and another thing is very nice about the paper is right. So from recent paper we see out of sample anomalies tend to weaken very substantially, but this paper provides one potential explanation is right, firm releasing information much faster. And the arbitrage industry becomes more competitive. So anomaly, they go away faster, right? So if we still stick to the conventional empirical procedure, then we may see an artificial weakening of anomalies. Okay, so this is a really nice point from the paper. Okay, so I have three main comments related to each of the key takeaways. The first thing is about whether anomalies are spurious or real. I agree with the author that the evidence in this paper shows the magnitude of anomalies might be underestimated. However, I would say the criticism in the literature it's a little more subtle. They do not say that all anomalies are spurious, right? So in fact, there are several very important dimensions in the cross section. For example, value, momentum, investment, and profitability. Okay, so if you look at the criticism, for example, data mining is a real concern, right? So different papers have taken different angle. For example, Harvey, in his presidential address, he talked about the pressure for publications, this publication bias, and then Harvey et al. They talk about the testing methodology. We need to think about multiple testing instead of treating each test individually. And McLean and Pontiff document out-sample evidence of anomaly decay. So, for example, they show you that the author seems to be picking the ending point of the sample period just to make the results stronger. Another line of critiques, for example, from my own paper with Lu and Kawei, is we show another contributing factors to the evidence is that the standard approach tend to allocate excessively to microcap stocks. So these account for 60% of all stocks by number, but they only account for 3% of the aggregate market. Okay, so if you use a more robust procedure, in particular using value weights, you see their magnitude actually a lot lower. The number of significant anomalies is also a lot lower. But still, so from our paper, we show that if you use the robust procedure among the 450, you still have more than 150 significant anomalies. So not anomalies spurious, but our point is many of them are kind of exaggerated. And finally, another point is, even though we may see hundreds of anomalies, but there are a lot of overlaps. Okay, so if you use 4 or 5 the key factors to explain them, you can actually capture a lot of them. Okay, so in other words, many anomalies, they're just slight variations of a few important ones. Okay. All right, so again, I agree with the authors that the evidence here really shows that we may be underestimating anomalies because we do not account for the changes in new information release and arbitrage environment. Okay. Second comment about how do we interpret anomalies? Okay, so again, I agree the timing patterns is very interesting, and I think it's more supportive of the mispricing interpretation. But in theory, I would argue the decay itself can be ambiguous. If we view anomaly variables as a proxy for discount rates, and discount rates can vary over time, for both risk or irrationality. So as time passes, portfolio starts to become more stale. So naturally we can see some amount of decay during the holding period, even without mispricing. Okay, so basically my point is decay per se may not be very informative. It's more about the amount. Okay, so to back up the mispricing interpretation, one suggestion I have is to document the patterns in arbitrage activities, such as trading volume or short interest. And if you can show very similar timing patterns, that is, for example, if you have a lot of trading volume concentrated right after information release, that will be very helpful. And I find the evidence on the changing timing patterns that's more informative. I think this provides a stronger support because intuitively, one would argue arbitrage, the industry becomes bigger, the arbitrage become more competitive over time. And hence, we see from table 3 of the paper that the realization of anomaly returns seems to be shifting earlier. So if you look at the second half, the higher percentage of the overall returns realized in the first 2 or 5 days. And also, as the author pointed out, for the first half, the 30-day returns is actually larger than the second half. So that reflects the industry becomes more competitive and arbitrage become faster. So related to my early comment is, can we also show the arbitrage activities have also shifted earlier? So if that's the case, that will be really nice to show. And I also noticed some interesting results from the appendix so this is related to earlier papers on anomaly returns on Newsday. Okay, but a little bit surprisingly that, so if you think the mispricing can be corrected when the market receives new information. So from, for example, Engelberg and all, they show that on the news days, the returns tend to be a lot higher for anomalies than non-news day. However, that does not seem to be the case, especially for the faster rebalancing. Okay, so I'm wondering what's the reason, and the author defined news day as either earning announcement or news coverage from Raven Pack. So I'm just wondering whether some of news days are not as informative. What happens if you only focus on the information release day? Okay. So my third comment is about the recent weakening or the out-sample decay of anomalies. So the paper cited one interesting study by Arif et al. That the percentage firms that filed 10K concurrently with earnings announcement has risen very substantially from 9% in 2002 to 43% in 2016. So in other words, a lot of the information we get for the non-earnings items, the financial statements, are released much faster than before. Okay, so if firms release information more quickly and arbitrage become faster, then just intuitively, the standard procedure forming portfolios in June and hold for 12 months, this can generate artificially weak anomalies. And here, some useful information can be helpful is maybe the authors can document the exact information lag, the excessive information lag between the release date and June end, and shows this information lag has been increasing steadily over time. So that will be helpful. Okay. So using the faster information, okay, so the economic gains are really substantial, and this seems to reverse the partially the weakening anomalies in recent years. So even though the caveat is the set anomalies here is only the accounting anomalies, okay. And interestingly, when you talk about mispricing interpretation, the literature often cited as the recent weakening as evidence that anomalies are arbitraged way because they are mispricing. Okay, so now with better information updating, one thing you would honor is if this decay is actually not there, so how can we reconcile the evidence with the mispricing imputation? And finally, about this point is I find the gains from faster information updating is really substantial, and it's almost arbitrage-like. So if you look at table 9, so basically, if you do a long-short strategy, you long the fast updating portfolio, you short the slow updating portfolio. So this amazing thing from this table is that the return, the spread is always positive in any individual years. And if you look at the Sharpe ratio, the Sharpe ratio is really high. Okay. So this makes me wonder what's the reason. So my sense is that perhaps likely the slow and fast hedge portfolios, they probably have very high correlation, right? So you have different returns, but the co-movements are very similar. So when you do long short, you hedge away the co-movement risk. So that's probably the reason why we see this very large Sharpe ratios. So I also have some additional comments. I think to make the analysis very neat on the 2 points on update, rebalancing, and the information release, the accounting anomalies is really, it's very sensible to be the focus, but I think the mechanism about mispricing being corrected after information release should also apply to non-accounting anomalies. For example, the valuation based on anomalies. So I wonder, what will be the timing patterns for other anomalies? And so from the presentation, we also see that there are results about hedge fund speed. So if hedge fund trade faster, we tend to see their future alpha is also higher. However, one issue here is the authors measure hedge fund speed using the beta. In other words, the correlation between hedge fund returns and the fast rebalancing portfolio. But from the earlier, the previous slide, so here, the fast and slow portfolios, they seem to be very correlated. Okay, and this high correlation means that a hedge fund can have a high implied speed even if it trades very slowly, right? Because it just had exposure to the style. So my suggestions will be either use the fast minus slow portfolio to compute the beta, or control for the slow portfolio beta for this analysis. Okay, and also another issue is just you may see a persistent alpha just because the Farmer French 6-factor models they cannot subsume the 28 anomalies. Okay. So 2 more relatively minor comments. One is when we measure abnormal performance, note that the Farmer French factors, for example, the value factor is based on the slow rebalancing, right? So naturally, this can be a problem. Okay, and I would suggest, maybe just focus on raw returns. I think you can make a point with raw return rather than a specific alpha. Okay. And finally, I would suggest using value weights to give proper weights to microcap stocks. Okay. All right. To conclude, I think this paper is really nice. That's a very novel angle, and I found the results to be quite interesting. So my main suggestion will be provide more corroborating evidence on the patterns of arbitrage activities. And I like the point, right, of the paper that it provides at least a partial explanation for the decay of anomalies in recent years. And this is a very important evidence when we think about what drives anomaly. And another takeaway from the paper is, right, when we do empirical work in asset pricing, it's really important to pay attention to shifting accounting practices, right? So accounting knowledge is important. Okay, thank you.
Okay, thanks, Chen. That was a very nice and detailed discussion. Boone, do you want to take a couple of minutes to respond, maybe?
Yeah, absolutely. Jim, thank you for the excellent discussion. And if you could send the slides, I took as many notes as I could. I've got, I'm not teaching this summer, so I've got all summer to incorporate this stuff from you, Chen. I appreciate that. Let me talk about a couple comments, because I think you're spot on a lot of stuff, and also gave me some new ideas. Your comment one, are anomalies real? Chen, you know more than anybody. That's a difficult question to argue with people. Are anomalies real? Our results are suggestive that they seem to have existed. They're not at least for our set of anomalies, they're not simply data mining. But whether they're real or not, you know, different versions of the paper as we worked on that have addressed that question. And currently we don't talk about that quite as much, because as you know, and as you highlight, that's a difficult question. To the Newsday stuff, the Engelberg, McLean, and Pontiff paper, I'm glad you brought that stuff up, because I didn't have time to talk about it in the presentation today. The table you showed was from the implementable version, the calendar time tests. And one thing I'll highlight is that we're looking at a different framework quite a different framework than the Engelberg, McLean, and Pontiff. But when we look at event time, they're finding that anomaly returns are higher on news days. We have replicated that finding in the event time, but it didn't show up in that table when we look at the calendar time. But regardless, we show that even when you're accounting for news days or earnings announcement days, the finding that anomaly returns still exist mostly after the information is released, it still holds. But finally, I'll mention thank you for this idea of looking at arbitrage activities changing. It's something I'm going to spend some time with in the coming days to try to incorporate that. I think that's a good insight. And again, thank you for all of those insights. Very helpful discussion.